Hello and welcome to another episode of the Temple Aaron steam boiler replacement. So right now you can see we've got the cast iron sections into the boiler room. God, it was windy that day, as you can see. So we have these two halves because they don't ship the whole block assembled because it's just too heavy and too unwieldy. Even these two halves are pretty hard to deal with. But we have to get these up onto the pad there and then flip them so they're horizontal. Line up these push nipples, which are those two silver rings you can see. That's going to be the connection between the two halves. And get it lined up and then get the bolts in and draw the whole thing together and compress those push nipples until they seal. You can see me putting on some fiberglass rope here. This is to seal the flue gases that rise up between the sections from the burners. So you can see how the space between the sections has all those little pins sticking out. I'll talk about that here in a little bit, but one point I wanted to make while we're doing this and you're watching us move these around is, with the video speeded up, it looks much easier than it really is. That chunk of cast iron there weighs about 450 pounds. And the other one's a little lighter because it's missing one section, so it's about 350 pounds or so. But the most important thing when doing this is safety. So you'll see us stop a lot. We talk, we have a plan, we make sure everyone is completely on board, knows exactly what their job is, knows exactly where they're going to be and what they're going to be doing before we ever even try the next step in moving it. So here you can see, we want to set it down nice and gentle on the support, make sure it's stable, and then we're going to get the jack under it, which has wheels on it. So once we prop that up, we can shimmy everything over and we can make sure that it moves easily. And you can see how well that went there. We get it over to the left-hand side, make sure it's where we want it. And then we're going to get another jack under this so that we can use the jack we're using here on the other side. The reason we do this is so that we can independently raise and lower each half as we try and line up those push nipples and get everything to seat correctly. But yeah, I just wanted to make the point that, anytime you're doing something like this, safety is paramount. You have to make sure that everyone knows what you're doing, everyone's on board. There's no questions, you don't jump the gun, everyone has to be ready, and you take your time and make sure that that is the case, because it does not take much. One thing slips because someone wasn't ready, and then they lose a hand or break their ankle or something like that. It can go wrong in a heartbeat. So always have to be very cognizant of that and make sure that you know exactly what you're doing and move on. And fortunately, everything went to plan. Everything worked very well on this. I'm pretty happy with how it went. So yeah. So next, you're going to see us get that other half of the block up onto the concrete, and we're going to use, like I said, that jack there to adjust the height of this side and ensure that everything lines up. I think one of the most um, most interesting things about doing this for me is that every single one is a little bit unique. There's, every boiler has kind of its quirks on how they like to go together. Sometimes you'll run into issues when you're tightening it together where the push nipples don't quite line up and you have to pull it apart, put new push nipples in, and redo it. There's always challenges. So I've had boilers that don't have the feet cast into the block like this, where you actually have to build a stand first and then lift the block onto the stand, and that can be kind of problematic because you only generally get one chance to do it, and you can't have your fingers under it. You got to use straps and stuff like that. But this boiler was actually, as they go, pretty easy to assemble. And it's always nice getting to this stage. This is kind of one of the biggest initial hurdles, is just getting this thing down here and making sure it goes together. I did not film any of the process of getting this off of the delivery truck and all the way down the side of the building and around the back and over all the bumps and stuff, because I didn't think that I would be able to really adequately film it and do it at the same time. So I don't have any of that footage, but you can imagine if you've ever been to the site, if you walk around the left side of the building and all the way down and down the hill around the back to get into that door, it was a little harrowing. But we got it, and everything worked out well. No one got hurt, so that's all you can really ask for. So little things always go wrong on jobs like this. Every single one. I've never had one go perfect. And right here, you can see one of those moments. Didn't look like much, but I brought my big socket set with me, and it goes up to 1 inch. And of course, the nuts on this, the draw rods here, are 1 1/16. So I didn't have a socket that fit. We tried for a little bit to do with crescent wrenches, but you just can't move the crescent wrench. It's too close to the boiler. So Zach said he had a 1 1/16 socket at his shop, so he ran to grab that. And this is me just kind of walking through with Dan how everything works. But he unfortunately had to leave, but that's okay because all the heavy lifting was done. So here's a little bit later, Zach got back with the wrench, and we started tightening up those draw rods. So if you watch real closely, you'll see the boiler slowly just start to come together. And as you do this, it's really important that everything is even. You make sure you tighten everything the same rate. You make sure that the gap between those sections stays the same as you tighten everything up. Make sure everything's level. You can see me just adjusting a little bit there, trying to get the boiler sections to be just right. And you can feel it as you're tightening it too. If it starts to bind, you know that something's not quite right. There should be kind of a steady, consistent, even pressure as you're drawing it together. And once you get real close, it starts to compress that fiberglass gasket between the outside of the sections, that kind of white line that you can see there. And then once you're all the way done, there are little standoffs that sit between those sections to keep the gap perfect at about 1/8 of an inch and make sure everything's straight. So once you hit that, it'll snug up real tight, and you just, that's it. That's all you need to do. And once you get there, you can kind of see me reach that point there. Walk around, check everything, tighten, make sure everything is snug. Right there, and right there, and the last one on the back right there. And I think one more last check on everything, make sure it's all at the same torque. And then we take the jacks out, and it's freestanding. Now, you can see it does rock a little bit. That's pretty normal. It's very rare to get this to work and be completely perfectly level and straight. The process of putting this together and having those machine push nipples, it's much more important that those push nipples are lined up and correct and torqued together than it is for both halves to be exactly perfectly parallel on those bases. So that's okay. All you do is shim it, and we're going to bolt this down to the concrete here in a bit. So once you get it shimmed up and you get it bolted down and anchored in place, it really doesn't matter that it's out of level at all. You level it with shims and make sure it's where you want it. So that's what I'm doing here, is just check every portion of the boiler, make sure I know exactly where I want it to sit. And in this case, splitting the difference between everything, the best place seemed to be to lift that back right corner as high as it would go, and then that would keep everything as close to level as it was possible to be. So here I'm just kind of checking, make sure I'm square with the pad and where I want, and then I'm going to mark all my holes using a hammer drill. The reason I don't use a marker or anything like that is that if I use a small drill bit on the hammer drill, I can get that exactly where I want it in the bolt hole, and then just mark a little divot, and because I have that mark, the bigger bit that I use to actually drill the anchor hole will follow that divot and center itself perfectly. So now I got to get the boiler out of the way to drill the holes, so use that jack and just lift it up just enough to move it. I don't want any risk of it falling over or pinching me or anything like that. And then here I'm drilling the full-sized holes for the actual concrete anchors I'm going to use. So you can see that, do one side, and then just shimmy it back out of the way, go do the other side, and get everything drilled, get it back in place and lined up, and we'll start putting bolts in. So I wanted to talk a little bit about, now that you can actually see one, I know I kind of talked about how cast iron sectional boilers work, but now that you've actually seen one and kind of seen the inside of one, it makes a little bit more sense to really talk about that. So this doesn't get completely filled with water. You have to have room above it to generate steam. So the normal water line that you want is about halfway up the block as far as you can see, not including those legs. But about halfway up that is where you want the water line to sit. And then when you put the burners underneath it and the burners fire, it starts to boil, and that gives room for that steam to come off. The two pipes that are going to come out of this to supply steam are on the far right and far left. You can see those tappings coming out. So those will join together in a header and then an equalizer. I'll explain all that when I actually do that, because that'll be its own video. But you know, right now I think the most important thing to realize is that in between each one of those sections, the sections themselves have water, or water and steam in them. And then between the sections, you saw all those pins. So those, those are where the flue gases are going to rise through the boiler and heat it up. And the reason all those pins there does two things. It turbulates the flue gases as it goes through it, which increases the heat transfer between those gases and the cast iron. And it also greatly increases the surface area. So those two things increase the efficiency of the boiler, and you get as much heat as possible from that flame actually into the water. Now, when you have a system that requires steam, one of the biggest considerations you have to take into account is the velocity of the steam. So if you can imagine this is all going to essentially be a closed system. There's no open, it's not open to atmosphere anywhere. It's not really like boiling a pot of water where you have, an open source of, a place for the steam to go. So when steam starts flowing through these pipes, you can get velocities of 60, 70 miles an hour of that steam flying out of this thing. And what that can do is it can actually suck water up with it. So that huge velocity coming out of the steam pipes into the header, if you suck too much water out and throw it out into the system, and you're not using just steam vapor, you get tons of problems. You get a lot of banging. That high velocity steam will pick up little slugs of water and throw it against the side of a pipe at a turn, like a 90 or a T. And that can cause you, can actually damage components like air vents. In bad enough cases, it can actually damage piping. Usually it doesn't, but it's not something you want to live with. It sounds like someone banging on the pipe with a hammer. So you have to have everything sized correctly, and that's all about the diameter of the pipe. On this boiler, it actually states in the instruction manual that you must have 2 3-inch risers coming out and a 4-inch header. Now, if you don't maintain that, if you, for instance, don't have the apparatus to thread above 2-inch and you put some reducers into that header and reduce it down to 2-inch, the velocity coming out is going to increase, and that will cause wet steam. It'll cause a lot of water to get sucked up with it and get thrown out into the system. So you have to be very careful of that. So you saw me get it all bolted down. It was a little tricky getting those shims in place, but got it to work. Here what I'm doing is cutting the fiberglass gasket for what's called the smoke breaching. So this is when all the flue gases rise between the sections. This is where they collect, and then they're going to go out the back and then through a draft diverter and out to the flue in the chimney. So here it's very, very important that you get all these gaskets perfectly lined up so that when you tighten it down, they compress correctly. So that's what I'm doing here, is just making sure everything is just right. And then there's 2 bolts, one on each side, and as you tighten it down, that fiberglass compresses, and you end up with a nice seal on the top of the boiler. so that all your flue gases will rise through the sections into the smoke breaching and out the chimney without going into the space. Because anytime you get flue gases into a space, you run the risk of carbon monoxide poisoning, so no one wants that. So here, just assembling the 2 bolts, tightening it down, and I think that is about do it for this video. So I hope you guys enjoyed. If you have any questions, you can email me at templeaaronboilerreplacement.org. Or sorry, templeaaronboilerreplacement@gmail.com. Thank you.